Okay. So as you guys might remember from yesterday, we talked about systems. Does anybody remember what we defined the system as being?
Nope.
Okay, so
Collection
it's
of processes.
a group of related components that create a greater whole, right? And so we talked about how human bodies is one example of a system, and the Earth is another example of a system. And when we talk about Earth systems, we usually talk about there being 4 components or spheres of the Earth. And one of those is that you're familiar with, I know right off the bat, is the atmosphere. Who can tell me what the atmosphere is?
The air in the sky.
Okay, good. So it's all the gases and clouds surrounding the Earth, right? We have a pretty good idea of what that is. Now, if you look at this picture up here, it actually shows all 4 of Earth's spheres in one photo. So while I put up the objectives, I want you guys to write in your journals what you think the 4 spheres of the Earth or components of the Earth system might be. Okay, so that should have been enough time for you guys to do that. Just quickly today, the objectives. By the end of the day, you all should be able to describe the flow of carbon through the carbon cycle, and we're going to construct a flow chart of the carbon cycle. So, going back to the Earth system's spheres or components, I already told you that one of them was the atmosphere. And we said that was the gases, water vapor surrounding the planet Earth, right? And I want you guys to be writing this down in your notes, please. Now, based off of the hint that I gave you, what do you guys think might be one of the other spheres or components of the Earth when we think about it as a system?
Hydrosphere.
Hydrosphere. So what would the hydrosphere be?
All the water.
All the water, right? So you guys have maybe heard of hydropower or hydroelectricity. So hydro is a prefix that we use to talk about water. So good. So the hydrosphere is another sphere of the Earth system. And that's all Earth's water. Okay, so looking at this, what else do we see that we think might be a component of the Earth system?
Biosphere?
The biosphere, yeah. So what would that be? How would that be represented like in this photo?
The people?
Yeah, good. So you guys are probably aware of bio as a prefix, meaning life. Okay, and so there's one more that we haven't discussed. What else do we see on there?
Fire.
Okay, and that's actually not
Cool.
fire though.
Lava.
It's actually lava, right? And then behind it you can see there's some rocks and mountains and stuff. So we call that, not surprisingly, the solid Earth, the geosphere, like geology, right? So that's minerals, rocks, and actually lava as well. But for simplicity, I'm going to call it the solid Earth.
What does geo mean?
Geo means Earth.
Why?
I'm not sure. I guess they had to come up with something that I believe it's Greek, but I'm not actually positive. But when you talk about geology, that's study of the Earth. Biology, study of life.
Is that the same beginning as geometry, which is like shapes and stuff?
I don't think so. That wouldn't make sense, but I don't actually know the difference, but I can find out for you. It's a good question, though. So anyways, now that we've defined these terms, I want you guys to just turn to like a shoulder partner and go over this vocabulary, just talk about it with each other for a quick second, and give an example of some sort of matter that you would find in each of the 4 spheres, just really quickly. So for example, okay, the atmosphere surrounds the Earth and you would find a cloud there. So just real quick for the next couple minutes, just talk to your partner about that one. Where would you find that?
Make up part of the geosphere.
What is this? Fishies? Where would you find the fishies?
Humans ruin the
Okay.
biosphere
What else would you see?
by polluting the atmosphere and poisoning the hydrosphere.
Okay, so going forward, for the rest of class, we're going to discuss how carbon fits in to each of these spheres. And in a little bit here, we're going to have a little bit of a game to play with it also. So we're going to be talking about carbon a whole lot in this unit because it's really important in basically everything that we're going to talk about concerning evolution, which involves all of Earth's spheres. So first of all, who can tell me what carbon is in general?
It's an element.
It's an element, right? Do you happen to remember, Sierra, how many protons are in carbon?
Oh, protons, I know it's atomic number.
Okay, so that's the same thing, right?
Oh, yes. Sorry.
So good job. So carbon is an atom with 6 protons. And typically, it's going to have 6 neutrons, so that's carbon 12. But there is also stable carbon 13 and a radioactive carbon 14, which we're going to be talking about more later when we talk about radioactive dating. So I just want to quickly talk about why, yes?
Mr. Shell, what does radioactive mean?
We're going to talk about that later. I don't want to get too off topic today, but I can talk to you about it after class too if you want. So first of all, why is carbon important to the biosphere? Does anybody have any idea?
Carbon life forms?
Yeah, so actually, every single life form that we know of has carbon in it. So first of all, it's an incredibly important element for the biosphere. Oopsies. And something we talked about earlier in the semester concerning the atmosphere with carbon. Why would carbon be a really important aspect of the atmosphere?
It keeps us warm.
That's right, and how does it do that?
Greenhouse effect.
Yeah, so CO2, carbon, can bond with oxygen and create CO2, which is a greenhouse gas, which we already spoke about earlier in the semester.
Isn't methane a greenhouse gas too?
Methane is a greenhouse gas, and that also has carbon in it. Yep. It's actually, as it's a larger molecule, it's actually pretty important, but there's just more carbon dioxide than there is methane. So good, okay. And so why, especially for us here in Wyoming, why do we think carbon would be important in rocks?
Oil.
Okay, yeah, especially here, we have a lot of coal, right? Which is carbon from ancient, mostly plant life forms. Okay, so moving on, the carbon cycle is what I really want us to start focusing on now. And that's how carbon is not only stored within all of the Earth system, but also how it transfers amongst different types of material. So this is a flow chart, which you guys should remember the general structure of, because we already did this with the rock cycle. So you'll remember igneous, metamorphic, sedimentary rocks, and we had all of the different arrows going back and forth. And then we also had verbs on those arrows to describe the processes that the rocks undergo to change forms. And so, I don't know how well you can see it, but these sort of darker purple boxes, represent material, or what we call a carbon store or a sink. So those are various examples of where we might see carbon. And then your blue boxes and arrows are a description of how carbon can change forms back and forth. And so again, the carbon cycle, when we say that, we're discussing where carbon is found in the Earth system, and then also how it changes forms back and forth. So what we're actually going to do now is, as a group, we're going to all come up to the front and we're going to play a game real quick. So everybody come up to the front for me. Okay, so what we're going to do is we are all going to represent an atom of carbon. And we're going to take ourselves on a journey through the carbon cycle. So I'll start us off, and what I really want us to do as we go along is think about which component or sphere of the Earth system we're in, and then how it is that we're moving into either another example of matter in the same system or out into a new system. So for fun, since we're in Wyoming and we have a lot of coal, I'm going to start out as an atom of coal, as a fossil fuel. And so if you look at these sheets, each one has directions. And what you do is you roll the dice, and depending on what you roll, it tells you which part of the carbon cycle to move to next. So starting out as carbon in coal as a fossil fuel, so that's part of the geosphere. I rolled a 6, so this says I'm going to go to the atmosphere. So what I'm going to do is look on our flow chart that I've already started out for us here. And so I started out as a fossil fuel, and I'm moving to the atmosphere. So I'm just going to draw an arrow, and then what else do I need?
How you got there.
Yeah, how you get there. So how would an atom of carbon go from being coal to being something in the atmosphere?
Burned.
Burned, right? Yeah. So, burn. Okay, so I want each of you guys to take a roll at the dice. Do you want to start, Stephanie?
Sure.
So now we're in the atmosphere. The moose is a 1.
Okay. One, stay in the atmosphere. Much of carbon dioxide in the atmosphere moves through the atmosphere.
So it's interesting, it doesn't really matter where we emit carbon dioxide because the atmosphere mixes so much that coal that we burn here in the Jim Bridger power plant can end up having an effect a half a world away. So you can roll again though, so we get you into something else and we get you to interact on the board.
Okay, 5. Go to surface ocean. Okay.
Okay, so you're going from,
Atmosphere to ocean.
yeah. So which sphere would the ocean be? Or which sphere, sorry, I erased them. Biosphere, hydrosphere, or atmosphere?
I thought you were making the...
Sorry, yeah. Okay, so you're in the hydrosphere now.
Hydrosphere.
And so this is an interesting one. How does carbon go from the atmosphere to the ocean, do you think?
Little, like, phytoplankton's in the...
So yeah, it is actually a result of that. So as carbon dioxide, which exists, like if you guys ever open a bottle of soda, you know, all those bubbles come out, and that's actually dissolved carbon dioxide gas. And so carbon dioxide can exist as a dissolved gas inside of the ocean too. And so as plankton or other photosynthesizing organisms take it out of the ocean, it actually diffuses from the atmosphere into the ocean. And we'll talk about that more later. But cool, good. I think we're running pretty low on time, so I'm sorry that not everybody's going to be able to get to play. Susan looks really sad. I'll do one more. We have 2 minutes, so.
Go back to the atmosphere.
Wow. Okay, so what would how would that happen?
So, would it be like the ocean gets hot and then it's like boiling water and it all just evaporates?
So yeah, actually the warming of the ocean can play an important role. But it's usually more of whether the carbon is in the surface of the ocean or lower down. Although, so it can happen a couple of different ways. It can expand and actually go, like it'll get released at mid-ocean ridges, and it can go all the way through. It can just diffuse in the same way, it's back and forth. Or decomposing animals can release it, it'll just go to the atmosphere like that too. So. Okay.
Couldn't aerobic respiration also release it?
You mean from?
Animals, they digest their food and they breathe out CO2, like whales.
Okay, yeah, so that's, yeah, no, you're right, they can do that.
Like
A lot of
the
times
whale eats
it-
the plankton and it breathes out CO2.
Whales typically go already to the surface to do that, but that's actually a good point, and whales are also part of the biosphere, as opposed to being actually dissolved in the ocean. But you're right, yeah, mammals that live in the ocean will respire CO2. And we're gonna talk more about respiration tomorrow, so. You guys go ahead and take a seat, we're out of time. Talk about the carbon cycle, how it flows through various spheres. Take out your journals and just write down for me again the 4 spheres of the Earth. And yeah, in my class, I would actually have all the kids do this on their own, and that would be my assessment, would be the flow chart that they created. So.